Hi, everyone. Welcome to the last session of SQLRally. How was it? Did you enjoy it? Great. So thanks for joining me. For the next hour, I want to talk about something that I think is very important. And it's about monitoring the execution of processes and queries in SQL Server. Whoever executed a process or a query and he had no idea when it's going to finish? Raise your hands. Everyone. So I hope at the end of this session, you'll have a few more techniques in your arsenal in order to know better how to monitor your executing processes and queries. Before I forget, I was asked to tell you that at the end of the presentation, please pass your evals to this podium, and we will draw this. I don't know what it is, but we will draw it. So that's that. A few words about me. My name is Matan Yungman. I work for Madeira SQL Server Services. We're a consulting company based in Israel, but we provide training services all over Europe. My blog is up there and my email. I'm also on Twitter. And I also have a podcast about SQL Server. It's a very fun way to learn new things about SQL Server when you're going to work or jogging or washing the dishes or whatever. Me and Guy, who's standing at the end of the room, we talk about SQL Server. We release a show every 2 weeks. We have 2 modes. One show a month, we go all over the place talking pretty much everything. And one show, we focus on a specific topic or a specific person. And this mix, I think it's good, and I hope you will check it out. OK, let's go into the mood. It's Friday. I know it's Wednesday, right? But let's assume it's Friday. Before your weekend, you're already planning where to go with your kids, maybe go to a vacation and all that stuff. But for some reason, it's 4 o'clock, and you decide that this is a good time to run one last script. Whoever had this problem? And this thing turns into a nightmare. So I know it happened to me, and I'm pretty sure it happened to almost all of you. So maybe you'll say to yourself, OK, I've been stupid. Let's roll back, right? So it might be a good thing, but it might be bad also. And let's see that. So what I have here is just a simple alter index command. And I will execute that. And we let it run for a few seconds. So, but what we do is we build this index in parallel with 4 threads. And we let it run for something like 30 seconds. And after 30 seconds, we'll understand we were stupid, and we will stop that. And then we will see how much time it will take it to roll back. So 30 seconds. Anyone want to guess how much time it will take to roll back?
3 minutes.
3 minutes. OK, you're close. You're close. And it's hard to say, but what we can say for sure that it will take more than the amount of time it took us until we stop the process. And why is that? Because when we execute a query or alter index in this situation, we can work in parallel. But when we roll back stuff, the rollback is single-threaded. So everything we did with 4 threads, we need to do with 1 thread right now. And it will take more time than the amount of time it took until we stopped it. So to be fair, most of the time it will be OK. But you need to think before you hit the stop button when you stop your queries and your processor. And we will let it continue the rollback, and we'll continue for now, and we'll talk about the agenda for today. So first of all, we will go over our toolbox, the DMVs that let us monitor our processes. We'll talk about the %complete column, which is a column in a DMV called sysdm exec request, which lets us monitor some of the processes in SQL Server. We'll talk about index build tracking. We will talk about identifying, executing batch in statements, and then we will monitor our running queries. Okay, DMVs. The first DMV is sysdm exec request. When we hit F5 in Management Studio, SQL Server generates something that is called a request. Every time we run a query or a process, we have something that is called a request. We take this DMV and cross-apply to sysdm exec SQL text in order to get the text of the query. We cross-apply to sysdm exec query plan in order to get the execution plan. And we have another DMV that is slightly different, that is called sysdm exec text query plan. And the difference is that when we use sysdm exec query plan, we get the execution plan of the whole batch. If we have a few queries that we run together, this is a batch of a few queries, and we will get the execution plan of the whole 3 queries, let's say. The problem is that if we have a batch of 20 or 30 statements, it will be quite challenging to understand what is the right query plan for the right statement. And that's why we need to use sysdm exec text query plan. It's much more convenient. For each request, we will in sysdm exec request, we will see the values for only the managing thread. And what is the managing thread? Let's say we have a parallel query. We have a managing thread and a few threads that actually do the work, but we won't see the threads that do the work in sysdm exec request. We will see them in sysdm OS task, and for this presentation, we will look at sysdm OS waiting tasks. Let's say we have 10 threads that run the query. Some thread can wait on locks, and some thread can wait on I/O, and some thread can wait on async network I/O, and so on and so on. We will see that in sysdm OS waiting task. We won't see that in sysdm exec request. And we will see some demonstrations about it later on. Another very cool DMV that was added in SQL Server 2014 is called sysdm exec query profiles. The need allows us to see the progress of the query in much more depth. And we will see that very soon. Okay, let's start with the % complete column. So as we said, this is a column in sysdm exec request. And it works when SQL Server knows in advance the amount of pages it has to process for the process. So which processes are supported? Backup and restore database, alter index, reorganize, DBCC check DB, check file group, check table, DBCC issuing database, recovery and rollback, and transfer database encryption. So when SQL Server knows in advance the amount of data it has to process, it can show us in the % complete column how much of the process is already finished. Another thing we can do is index build tracking. For online index operations, it's very convenient, actually. We can use either profiler or extended events in order to monitor that. For offline index operation, this is more tricky. We have to know in advance the amount of pages the index has, and then we can guesstimate when the process is going to finish. And let's see a demo about those two things. And this rollback took almost 3 minutes. 2 minutes and 40 seconds. You're almost correct. Okay. So what we need now is backup and online index. So for a start, we will take this backup database statement, and we will execute that from another tab. And now we will go to the sysdm exec request DMV, and we will look at the % complete column, and we can see that we are almost 30, 35, 40, and so on and so on. And using the estimated completion time, we can guesstimate when we're going to finish in 5, 4, 3, 2, 1, and we're done. Okay, so for backup, for instance, this is very accurate. So this is very nice. So this is the percent complete column. And now let's talk about indexes. So what I have here is a profiler window. And if we look at the definition, we can say we have an event called progress report online index operation. And we will start this trace. And for a start, we will rebuild this index with max drop of 1, with a single thread. And looking at profiler, we can see that the begin data 1 is the number of rows that were processed. Sorry. And the begin data 2 is the thread, is the number of threads, the thread number, excuse me. So if we have a single thread, this column is meaningless. On the other hand, we will clear that. When we don't limit the number of threads, and we build the index, and going back to profiler, we can see in the begin data 2 the thread number, and again in the begin data 1 the number of rows that were processed. And we can see that each thread handled the same amount of rows. Okay, so this is very nice. This is for online index operations. We can do the same thing with extended events. It's just more convenient to show that in profiler, but it's a best practice to use extended events rather than profiler. Okay, for offline index operations, this is more tricky. What I have here is a query from sys indexes, sys partition, and sys allocation units, and I go for a specific index I am going to rebuild. And what I see here is that the amount of pages for this index is 3,700 and something. So now I know in advance the amount of pages I have to process. And I will take this, and from a new tab, we are session 56, we rebuild it, and when we hit SPU2 56, we will go to the disk I/O and see this is almost the same thing, 3,721. Okay, so for small indexes, this is pretty accurate. For bigger indexes, it depends. And also for online index operation, the amount of disk pages that we process will be twice the times the size of the index. And this makes sense because we have to maintain two index trees. Okay, any questions for now? Okay, let's move on. So this was backup and online indexes. Close that. Okay, let's return to the slides. Okay, now we're moving on for query progress tracking. And for a start, we will talk about the most confusing weight type in SQL Server, which is called CX packet. Anyone knows how to explain what CX packet is? Okay, so CX packet stands for class exchange packet. And this is an actual class in C, in C++. And what it means is this is the only place where threads exchange data in SQL Server. So this means class exchange packet. Threads generate packets, and they exchange the packets between them. And it works pretty much like that. We have producer threads at the top, and we have consumer threads at the bottom. And in the middle, we have a buffer. So the producer threads move the packets into the buffer, and the consumer threads consume those packets from the buffer. And when the consumer is the one that's waiting, it means that the producer threads don't generate the packets fast enough. Okay? Is that clear? And when we look at CSDM OS waiting tasks, at the resource description, we will see something called e-wait pipe get row. Very descriptive, right? So this is what we will see. And on the other hand, when the producer threads are the one that's waiting, it means that the buffer is full and the consumer is not consuming the packets fast enough. And this will generally, most of the times, mean that your application, whether it's SSMS or the application, doesn't consume the rows fast enough. And that's why the producer threads have to wait. Now, the issue is that CX packet is usually not the problem. Anyone knows Thomas Kaiser? He's a Danish guy, really knows this stuff. And I heard a sentence he said that said CX packet isn't the problem. CX packet just means there's a problem somewhere else. Okay, so this somewhere else can be I/O, can be locking, can be network, and so on and so on. So CX packet is usually not the problem. Okay, so we will go to SysDM OS waiting tasks, and we will get something that is called the node ID. When you will look at the execution plan, each operator, let's say it's index seek or index scan, or the select, and so on, each one has a node ID. And we will go and grab this node ID, and this node ID means that the subtree under this node ID is currently being processed. So let's say I see a CX packet wait, and I see node ID 10. So this means that the subtree under node ID 10 is currently being processed. And it will be more clear when we look at an example. Okay, so we will open two files. And I apologize, I forgot to show you something. So it will be pretty quick. I forgot to show you how to identify the currently running query. So let's see that. What we see here is a batch with a few statements. We have three of those statements, and we have a query. So we will run that in a minute. And what we have here is we look at SysDM exec request, SysDM exec SQL text, and SysDM exec query plan. So let's run that. And this one. And it will take a few more seconds. Okay. So we close this trace because it interferes us. Okay, so what we see here is a few things. We'll zoom in. Okay, we see the running statement. If you remember, we had a batch with a few statements, and this running statement means that this statement is the one that is running right now. On the other end, we have this column, the current batch column, which shows us the whole batch. Okay, so we both have the whole batch, and the whole batch can be a stored procedure, and we have the query that is currently executing. So this is how you can identify the query that is currently executing. And these two columns are from SysDM exec SQL text, and we also have a column called the query plan from SysDM exec query plan. And do you remember we had two DMVs, SysDM exec query plan and SysDM exec text query plan. And the difference is that for query plan, we see the execution plans of the whole batch. And if you have 20 or 30 statements in the same batch, it can be quite frustrating to find the right query plan. So we can use SysDM exec text query plan. We will execute. We will execute it again. And in a few seconds, we will get the query back. And when we hit on the query plan, we can see the query plan for this specific query. Much more convenient. Okay. Sorry about that. Now, let's talk about CXPacket. Okay, what we have here is a query written by Paul Randall, and it goes to sysdm waiting tasks and to many other DMVs. And when we run our query again, and run pause query, we can see a few interesting things. We have the node ID column, which is derived from the resource description column, and we can see we have weights on node ID 1 and node ID 8. And when we look at the execution plan, we can see that node ID 1 is this one. So this means the subtree under node ID 1 is currently being processed. And it's pretty clear. Not really interesting. But node ID 10 is this one. Is this subtree. And this subtree means that the big transaction history table, that the select or the join part of the big transaction history table is currently being processed. Okay, and just to prove that, we can use the dbcc page command. If we go back to the DMV, we can see that in addition to the CXPacket weight, we have a page IO latch weight. And if we take the resource description and copy it here, we will get this beautiful output, and we will search for the object ID. And when we take the object ID and put in the object name function, we can say that this is the big transaction history table. So I wasn't lying. Okay, so this is the page IO latch issue, and let's see another example. Now I will update in a transaction the big product table. We have a join between the big product table and the big transaction history table. And I will update the big product table, but I will not commit the transaction. So now we have a lock on the big product table. And we will execute the query again. And when we go back and execute pause query, we can now see a weight on node ID 3. Okay? And what is node ID 3? Node ID 3 is the parallelism operator that is on top of the big product table. Okay? So as we said, this node ID of the CXPacket weight means that the subtree under this node ID is currently being processed. Okay? Is that clear up till now? Okay. Another thing we can see here in the resource description, if you remember, we had two strings in the resource description. One is wait pipe get row, and one is wait pipe new row. So wait pipe get row means that the producer threads are the ones that's waiting, are the ones that are currently waiting. On the other end, we also have the wait pipe new row issue. So we will roll back our update, and we will execute another query. And now when we run pause query, we can see the E-wait pipe new row. And this means that the producer threads are the one that's weighed in, and that's because Management Studio doesn't consume the rows fast enough in this case. And how do I know that? Because in addition to the CX packet weight, I also have an ASIC network IO weight. And this is another weight type that is not really descriptive and not well documented. But what async network IO means is that your application doesn't consume the rows fast enough. Okay, so in this case, as we said, we will have the E-wait pipe new row resource description. Okay. Anyone knows this trace flag? And why I used it? The reason I used it is that this original query gets a serial plan. And we can't use the CX packet method when we have a serial plan. And that's why I forced SQL Server to use a parallel plan using this trace flag. Now, this is not documented and not supported, so don't use it in production, but you can use this trace flag in order to understand where's the underlying problem. Using this method of CX packet and the underlying subtree, you can understand where the problem is. So this is how you can use this trace flag. Also verify that you get more or less the same plan. Because if you have a serial plan with the nested loops and a parallel plan with the hash match, it's not really the same. So you need to watch out for that. OK, so everything is clear with the CX packet method? Great. So now let's talk. How am I on time? OK, 30 minutes. Okay. Now let's talk about sort. So sorting is a very expensive operation, one of the most expensive operations in SQL Server. And we do have a method to identify when we are sorting. So if we look at this execution plan, before we execute this query, we can see that SQL Server estimates that the sort will take about 52% of the execution, okay? But he's wrong. And how do I know he's wrong? In this case, that's because I used variables. And when we use variables inside stored procedures or batches, SQL Server doesn't know the values of the variables. It doesn't look at them. So this can lead sometimes to bad plans, bad execution plans, because SQL Server doesn't know the value and it uses some kind of heuristics, and a lot of times it doesn't generate the right execution plan. And just to show you, if I use constants in this case, SQL Server will show me that it's not 52%, but 94% of the plan. Oops. 94%. Okay, so what happens when we execute that? We will execute this query. And we will run post query again. And what we can see here, oops, we'll run that again. Okay, it took some time, but it worked. We can see here something that is called I/O completion. And I/O completion is a wait that happens when SQL Server has to store some things on disks that are not data pages. And what this means in our case is that SQL Server has to spill the temporary data, the temporary sorting data, into TempDB. And this is where things go bad, because we have to go to TempDB, we have to go to disk, things are much slower. Sorting is already an expensive operator, even if we do it in memory. And if we go to disk, it's even more expensive. And I just want to show you that, so we will wait a few more seconds. And when it finishes, we can see on top of the execution plan an explanation mark that says that SQL Server spilled data into TempDB. You can see that starting SQL Server 2012. And there you go. Okay, so this is the sort. This is the problem with the sort. You can see this yellow sign, and that's a problem. So the method to understand that we have a problem is searching for this I/O completion wait type in sysdm OS waiting tasks. Another similar wait type to I/O completion is a sleep task. This is also something that happens when SQL Server sorts and spills data into TempDB. Okay, so now when we see the I/O completion wait type, in this case, we know that the problem is in this sort, okay? But what happens when we have two sorts? We have this sort and this sort. Now we're in problem. So we can use the sysdm exec query profiles DMV in order to see that. So let's see sysdm exec query profiles. So we need this one. We will go back to this query in a few minutes. So we will use this query again. And sysdm exec query profiles is a new DMV in SQL Server 2014, and it shows us per operator, per thread, the amount of rows that have already been processed by this operator. And in order to enable sysdm exec query profiles, we have to include the actual execution plan when we execute a query, or collect the actual execution plan using profiler or extended events. Beware that this is very expensive operation. So do that only for specific queries and specific situations, because it can hurt your system. So for our demonstration, we will include the actual execution plan and execute the query, and query sysdm exec query profiles. Okay, and when I run this query again and again, we can see that the row count is growing. We have the estimate row count and the row count, and the row count for the index scan operator, which is node ID 10, is going up. 5 million, 6 million, 7 million, and so on and so on. I have a problem with my Zoom it today. Okay, so just that we see, this is node ID. Oops. This is node ID 10, and now in SQL Server 2014, we can know how many rows were processed by this operator. Okay, it's not cheating like in CXPacket. CXPacket, the CXPacket mode was kind of cheating. This is the real stuff. Okay, so for each and every node ID and for each thread that is that's doing the work, we can see the amount of rows that were processed. Another thing we can do is identify queries that the row count is bigger than the estimate row count. Basically, when the optimizer has to generate a plan, it estimates the amount of rows that will go out of each and every operator. And a lot of times, the optimizer is mistaken. And that's when we get bad plans and bad performance. So we will use this query. And we will use, I will again use a variable to mask the value from SQL Server and execute this query. And when I go back to SysDM exec query profiles, we can see that the estimate row count is 3 million, but the row count is actually bigger, 8 million, and so on and so on. So this is another thing I can do with SysDM exec query profiles, which I couldn't do before that. Okay, and then another thing I can do is show the aggregated data if I group by the session ID, physical operator name, and the node ID. If I don't want to see rows for each and every thread, I can see them at the operator level, grouped by the operator level. Okay, any questions up till now? Okay, so the work we've done so far is a little tedious. You saw I'm going back and forth for the query, and then I get to the execution plan, and I have to go between the text and the execution plan, and so on and so on. And I have to identify which node ID it was, and I basically don't have a good visualization of where in the query I am right now. So what if we had that? So that's why I wrote this mod utility. And it does two things. It uses the CX packet way that we showed, and it uses the SysDM exec query profiles way that we just saw. And of course, the SysDM exec query profiles will work only on SQL Server 2014. Now, a disclaimer, I'm not a developer, and I'm not a designer. So the app might crash, but I see it as an inspiration to someone who knows how to write code that will do something good about it. So let's use the CX packet way. And we will go back and close that, and close that. And we will open this file. And we will use our famous query. And we are session 52. We'll run that and type 52 right here. As I said, I'm not a developer. We'll run that one more time. Let's run that. And hit 52 again, and stop the query. And run it again. And now we can see visually where we are in the execution plan. We know that the index scan of the big transaction history table is currently running. This is something I would word again. As you can see, I'm not a developer, not a designer, but if someone knows its stuff in designing, it can really help us. So I hope someone will take it, make it better. And for more complex queries, we can see we will be able to see the red arrow going on, and so on and so on. So I think it finished. I think it finished, but we can run it again. Oh, it's still running. It's still running, and it's still waiting on this subtree because it's still reading from it. That's when we won't have CX packet on this node, it won't be read. And let's say I would do the same thing I did earlier. I would update the big product table in a transaction. We will see a red arrow here. Okay? So let's stop this query. And now let's see it in the SysDM exec query profiles way. Oops, sorry. We need to include the actual execution plan and run it again. And 52. And we wait. Okay. So it took too much time, but at the start we would see only this part, and now we can see that all of those operators are currently working. Okay? And let's see another example. Do you remember our two sorts? We couldn't identify which sort is currently running, right? We can do it with one sort, but we can't do it with two sorts, okay? So now with these query profiles and this beautiful visualization, we are able to do that. So let's run that. Let's hit short plan, and it might crash again. It has a problem when switching between plans. Close program, and run it again. 52, and let's see. Okay, so what? Let's stop that and run it again, because I want to show the whole process. We'll execute that and show plan. And now we can see that everything that's to the right of the first sort is currently being processed, okay? So what happens now is the sort gathering the rows from the operators to the right of it. And now the rows moved on to the second sort. And now the second sort is currently gathering the rows. Okay, and when we hit the show plan, in a few seconds, it will go on, okay? So for the first time, we can know which sort is currently running. So this is pretty nice. And anyone seen anything weird with the sorts? Anyone knows what the blocking operator is, or iterator? So a blocking iterator is an operator that blocks all of the rows from continuing on to the rest of the plan. And sort is the classic blocking operator because it has to gather all the rows, sort them, and only then it can pass them on. But we see something different here, right? Because the sort is currently working, but it also passed the rows on. So that's pretty weird, isn't it? So what turns out is that the sort is indeed a blocking operator, but not completely. It has some interesting algorithm for sorting, and starting a certain stage, it can pass on some of the rows he already managed to sort. Okay, so it doesn't have to sort all of the rows before moving them on. Okay, so and I talked about it extensively in SQL Server Radio, and I talked about it with Paul White, who is something like the #1 expert in the world for the query optimizer, and it turns out that the algorithm, the sort in SQL Server uses allows it to do that. So this is another thing we can see using system exec query profiles. I didn't know that before. Okay. So we saw system exec query profiles, and we saw this utility, and you can go to this address and download the utility, and if someone knows how to write code, make it better. And I hope someone will do that. So I will leave that. Any questions? Okay, so please explore everything PASS has to offer, and stay in touch. And thank you very much for joining, and have a good trip home.